Here's a quick look at some remaining types of processes. They don't fit so well into a single family. They're all very quite different. Here's something we might call distortion, but it also gets called clipping or fuzz or saturation or overdrive. Those are all just different aspects of the same kind of a thing. A distortion process involves amplifying something and then chopping off its tops and bottoms. Now, that's likely to make sharp corners, which might be more harsh than you might want, so it's often common to see some sort of filter to tame down the high frequencies. Remember earlier in the semester when we talked about the sampling rate and the bit depth and the artifacts we get when we use sampling rate and bit depth values that don't suit the sound? Well, we can actually exploit those creatively. Downsampling refers to pretending that we had a different sample rate, or actually imposing a new lower sample rate on there so we can get the aliasing effect, these high frequencies folded over back into our sound because they're above the Nyquist frequency. The frequency components in our original sound that are more than half of our sampling rate get reproduced incorrectly, and it can make for a nice shimmering effect. At extreme values, you can get parts of the sound seeming to go up in frequency while others are going down, and so more of a squishing effect. If instead of the time dimension, we think of the amplitude dimension, the vertical dimension, we can impose a lower bit depth, which forces our sound to get more jaggies, like in a low-resolution image. Instead of a squishing sound, it tends to be more of bursts of noise, which you also might want to tame with a filter. And so we might call this bit crushing or bit munging. Now, you've seen pitch shifting before, but I want to highlight that you can also use it as a plugin, which allows you to take advantage of automation. And so whenever you can use something as a plugin running on a whole track rather than as an effect on a single clip, you want to do that. Think like an audio person, not like a video person in this case. Pitch shifting has a value up and down in semitones or adjacent notes, black or white, on a piano keyboard. Normally limits you to 2 octaves, but if you put multiple pitch shifters in series, then you can set one to the maximum and then use the other one to shift even further in that direction. There is a wet-dry control, and so sometimes you might want to hear only the pitch-shifted version, or other times you might want to mix in multiple pitch levels of the same sound. So pitch shifting is the result of multiplying every frequency component by a certain number, so that if you multiply all of its components by 2, the whole sound would be an octave higher. What happens if you add something to every frequency component? That's what gets called not pitch shifting, but for the sake of being slightly different and a little bit more sterile, frequency shifting. Frequency shifting breaks the harmonic series, and so it pulls harmonic sounds out of a harmonic progression, but only slightly if you only do it slightly. And you can do that in the upward direction or the downward direction, and it has the effect of spreading it or collapsing a harmonic series. Now, we've heard the term modulation before, and remember, modulation is just a fancy way of saying that you're changing something. And so the question is, what are you changing? Previously, we were finding ways to use low-frequency oscillators to modulate our delay period, or we were setting something in motion that was continually increasing or decreasing our delay period. That gives us effects like the flanger in the chorus when you modulate the delay period. Something that often just gets called modulation because, they just don't want to get into it, really should be better be called amplitude modulation. Or sometimes it's called ring modulation because you use a ring of diodes in order to make it happen if you're building the circuit. Not because it makes a ringing sound, although sometimes it makes a ringing sound. Anyhow, amplitude modulations means we're changing the loudness. Well, how could that be interesting? Well, it gets interesting when we change it so fast that we leave the realm of feeling things as rhythm instead of sensing them as a singable pitch. If we change the loudness of a sound back and forth at a rate that's faster than 20 hertz or so, it starts to result in changes in the timbre. Since we change the loudness by multiplying our sound by a number, 0 for silence times 1 for full volume, if we're multiplying it by a changing number, we need a changing waveform to dictate how that number changes. That could be a pure oscillator, and often it is, and so we can just pick the frequency of that oscillator, but you can also load other sounds and use that to modulate the new sound. Now remember, these are all numbers between 0 and 1, so the lower they get, the quieter each sound gets, the quieter the result is going to be. And so you might find yourself needing some makeup gain or some compression to make up for it. But this starts to become one approach to making hybrids between two sounds, which you might call an approach to cross-synthesis. So with these and all the processes we've talked about so far, remember automation. Take control of your sounds musically, expressively. Don't just set them and leave them, not all of them. So remember to click the toggle to turn on automation mode and then make your track height big enough that you can see the drop-down menu, and it will show you the effects that have parameters available for you to automate. So find the effect that you want to change, pick its menu, and from its menu pick the parameter that you want to change, and then you'll get this rubber band that stretches between points. You could also call it a breakpoint function that lets you script how those knobs should change over time. Use them musically. So not only can you make something fade in and out over time in a straight line or a jagged line, but you can also have something move between left and right. Automate your panning. You could automate filters, have your sounds become gradually fuller or gradually thinner or more or less pitched over time by changing the cue. Try automating your reverb, making sounds seem closer or more distant, and traverse the space between the foreground and the background. How about the threshold of a gate? You could morph between a rhythm that's more dense or more sparse just by automating that threshold. Instead of just fading that sound in and out, you could have it peter out on its own while keeping its loudness. And if you can do that, you can sculpt and do some of your composition in your automation curves. You can make motifs happen. We've seen a number of pieces that have sweeping filter patterns. This is how you can achieve that. You can build some pitch structures in terms of resonant frequencies or in terms of pitch shifting and have that be part of your compositional decisions as a new entire dimension apart from the source sounds that you record and the processes that you pick to do them. You can sculpt them live, make them dance instead of setting and leaving them, and have your composition come to life expressively through automation.